rocket ship. The model rocket is launched from the roof of the building. The flight path is modeled by blah. Remember, model rocket, roof of building means it has some initial height. That initial height is your C value. The C value is always going to be your y-intercept when you're in standard form. It always is, because that means that's when x is at 0. Okay? So he has some initial height here. It goes on, and then it hits the ground at some point. It could go backwards over here, but we don't want to do that. Whenever you're given problems that are clean, you're given problems that have a fairly decent looking setup to them, it wants to know what the maximum height is. You can go ahead and throw this in your calculator and you can calculate maximum. Honestly, I see really nice clean numbers. Opposite of b over 2a, and it gives me 3. It gives me an x value of 3. I know that this occurs at 3 comma something. Well, negative 5 times 3 squared plus 30 times 3 plus 10. 3 squared is 9. 9 times negative 5 is negative 45. 90 minus 45 is 45. 45 and 10 is 55. Now, Hannah, when you did that in the calculator, when we did that second calculate maximum, your x value wound up being like 2.9999. You can go ahead and call that 3. Because what happened was, if you don't approximate your left boundary and your right boundary close enough to it, you could have some rounding error, which is fine. You'll be able to distinguish a lot of times with these things. And I know most of you guys have seen that before, so it's not a problem. There's your maximum. Done. Real fast. Yes, ma'am.
When I put that equation into the calculator, it gives me 3, so then do I have to plug 3?
You don't have to, because in the calculator, then hit second table. Look what happens. Your calculator, when you go to your table function, is a giant plug and chug machine. And 3 is already there for you.
We are allowed to use our calculators, right?
Yep. See how that works?
Yeah, these ones?
Yes. The walking or the water balloon. Water balloon is ugly. I wouldn't say it's ugly, but it's got uglier numbers to them. A lot of times, yes, sir.
Is there a way to make y in the first one?
I don't believe so. What happens a lot of times here is you guys have a hard time distinguishing what do the x values represent, what do the y values represent. When you read the questions, it tells you. In this case, t is time in seconds. H is your height, I think, in meters. Must have been English because it's meters. So you know that there's some height and there's some other stuff. There's some initial height to it. It's a negative, so it's going to have a maximum. I'm sorry, it's down like a frown. Here's some initial height. And going through the questions, how high is the balloon after 1 second? Well, that just means t equals 1. What is h? Well, this style problem, I go directly to my calculator and I fill in the blanks. I put this in there because, like I said, this is a giant plug and chug machine. Negative 4.9x squared, 27x, and a 2 plus 2.4. And if I go right to my table, at 1, how high up is it? 24 and a half. It's there. Okay. For how long is the balloon more than 30 meters high? Now, remember the water, what is it called? The fireman hose one, where we were looking at what two values could have equaled 25? This case here, it's thinking about, in this graph, for what interval between what values is the balloon higher than 30 meters? So what we need to do is figure out, well, where does it become where the y value is larger than 30, and for how long is it above 30? Does that make sense? So there's two ways of going about it. We can go and just look at the interval and just say an about. This one didn't say to give us a specific answer like rounded to a certain amount of decimal points. If it doesn't say round to a certain amount of decimal points, all I'm going to do is go right to my table. And I'm going to look in here for where it was larger than 30. Let me move this over so I can blow it up. It starts above 30 here, and it drops below 30 here. So for how many seconds is it above 30? 3 seconds. Now, if I ask you to give me a specific allotted time rounded to the nearest hundredth, there would be a different way to do this. So if I say give me a specific value rounded to the nearest hundredth, I would then expect you to do this. We want to know where is it above 30 and for how long. We're going to calculate the exact value in second when it hits 30 and when it drops below. So we put in a second graph of y equals 30. You okay with that? Then what I'm going to do is move my window around a little bit to see this a little bit cleaner. So I'm going to change my window to like, what is that, maybe 0 to 10. And my y minimum, I'm going to put it at just 25. And maybe make my maximum 45 just to be sure I see everything. And go back to it. The calculator will find the specific values for where it starts and where it ends by hitting second, calculate, intersect. Very good. So first curve, let's see if I can find here. So here's my first curve. I'm on the blue, I'm on the right-hand side, I'll hit enter. Second curve, it wants me to be there. I'll hit enter. Guess, I don't know. It intersects it at 4.15 seconds on one side. And then if I do that again, second, calculate, intersect. Your calculator is so much faster than having to sit here and do this. And that one's at 136. So in my idea here, 136 and 415. Between those two values is how long it's above 30. You just subtract. What's the distance between those two? Technically, it's a little bit less than 3 seconds. Yeah, you can adjust your table set by using table set. That delta x, I think usually it's scaled to go by 1. You can change it to whatever you want. You can do that if you want. It's not a big deal. It'll take forever to go scroll through stuff. Okay. What's the maximum height of the balloon? Again, I'll have to do second calculate maximum. I think that would be okay. You all right with that one? And then lastly, when did the balloon burst as it hits the ground? So back to the original graph, we're trying to calculate for this value here. What is that value called on the graph? Otherwise known as the 0. So you calculate your 0. And that'll give you the x value in which it exploded with kaboom. Death and destruction.
How did you calculate that? How did you calculate that?
You know what? I wasn't like this. I really thought I was going to do that. Are we okay on the water balloon one?
Sure.
How do you find the 0?
How do you find the 0? Second, calculate 0.
I got 30.
Why did the intersection?
That's all it is. That means for some reason you had a stat clock turned on. Hey guys, if you ever get where it says you have an error for a graph and it says you have a dimensional error, all that means is that you have a stat plot turned on. In order to fix that, if you hit second y equals, you go to your what's called a stat plot. It's how we plot histograms and things like that. If that first one might say on, you just click on it and it turns it off automatically. If you can't figure all that out, just do a hard reset. Second memory 712, second memory 722.
I won't remember that. There's a reset button at the back of the calculator just resets the second.
Because yours graphed it. If yours wouldn't have graphed it, if it wasn't.
Can we just press the little button on the back?
Is that? I don't think it was a reset. You have to actually do the hard reset with the button.
It says it resets the RAM.
Okay. But if you do the 722, it also does a default. Rectangle. She is walking in a rectangle world. Next he is walking in a 15 meters diagonal across a rectangular field. So she's walking 15 meters diagonally. Her total distance is 36 meters. Which means if she walked 15, how many are left? Now, she hung a left and walked back this way, made another hard left and walked this way. Well, we don't know how far this is,
So that's X.
which means how much is left for here then?
21 minus X.
Hey,
This is really stupid. Whenever
now this is a right triangle.
It's a Pythagorean theorem.
It's a Pythagorean theorem. X squared plus the quantity 21 minus x squared equals 15 squared.
And that foils out to a really funny number.
Really funny number. Not as like funny ha-ha, but really funny
Funny
ugly.
isn't scary.
Yes. So you get, when you FOIL everything out, move stuff around, you're going to get 2x squared minus 42x plus 216 is 0. That's after you FOIL everything out and combine like terms. Yes, sir.
Do those triangles have to be 30, 60, 90?
They don't necessarily have to be. You cannot assume that they are.
Oh.
You can't assume that because if it was, one of these would have had a root 3 next to it. The other one would be double it. Don't make an angle side out of you and me. Right off the bat, when I see this, I know I can do multiple methods to solve this equation. Personally, I see that they're all even right away. I'm going to take the scalar out. Buy a dinner. Maybe go to a movie. I don't know.
Oh, I get it.
It's just a real bad. That's not that great. And now I ask, what times what is positive 108 that I add together and I can get negative 21? 12 and 9. The reason that you don't know that is because you probably don't use a tape measure very often. 9 feet is 108 inches. 10 feet is 120 inches. That's how I figured that out. You still can calculate zeros by throwing this in the calculator. It will work. You're going to get x minus 9 and x minus 12. You have possible zeros then at 9 and 12, which means if x is 9, what's that side like? 12. And then x is 12, this side is Those are your answers. Those are your dimensions. 9 by 12. It's a 3, 4, 5 triangle.
I got 63.1.
You've done 2.
And I checked it. 6 squared plus 321 squared is 6.
Ali got 9.
But 6 you get 3 plus 3 1 doesn't equal 36. Oh.
I guess for this one, I got an answer that came out 465 simple.
Rectangular lawn.
I just want to guess for this one, I think I got it.
Don't make her do factors.
Do it.
You should. You did.
No. This is not happening.
Why not?
Oh, that's flowers.
They make me think of
So we have a flower bed.
It's a flowers one.
The rectangular lawn measures 8 by 4, and it's surrounded by a flower bed of uniform width, which means my lawn is 8 by 4. My flower bed has same width all the way around, which now means that from here to here is 8 plus an x, otherwise known as 8 plus 2x. So it's an 8 plus 2x for one side. The other dimension is now 4 plus 2x. And that overall has to equal how much? 165. This problem is not asking you to subtract anything out. It gives you the interior dimension. You're adding out of it on the outside to get the full exterior. Yes?
So you weren't supposed to take out the interior part?
Not in this case. So a little bit of FOIL in here. We wind up with 4x squared plus 24x minus 133 is 0. At this point, what I would do is use my calculator or quadratic formula. I know I can find zeros rather quickly in the calculator by throwing this in there. Let's see. 4x squared 24x minus 133. Oh, I gotta change my window again.
Our songs and
I'm gonna have no homework this week. Testing
Oh, flip-flop my windows.
2, 5.
So I just did a quick 25 by 25. Now, can I have a negative width? So do I care about the 0 on the left? No. In this case, I don't even bother looking for it. I'm just going to calculate for the 0 here. Second, calculate 0. Left bound, let's move it around. Basically, I'm looking to be here, here. Guess. I get 3.5. My value actually 3.5. And that's where you got 7 over 2. The other one you had it negative, and that's why you think about it. You can't have a negative value because you can't have negative width. Okay?
So on the test, we could, like, if once we get it down to formula, we can just enter it into the calculator.
Yeah, that's what I hope you would do. I'm not going to factor that. I could complete the square. Right. The last one, the really pretty fancy schmancy mural. Had a lot of discussion on this one throughout the day today.
Probably wrong answer.
There, we'll do it this way. So I have this super fancy mural.
Wow.
I know. It's pretty awesome. It's something. The mural is to be painted on a wall that is 15 by 12. So the overall dimensions of the wall is 15 by 12, which gives the wall a surface area of what? 180. The wall has a surface area of 180. I know that. Second sentence. Welcome to my world. A border of uniform width is to surround the mural, which means all these values are going to be the same going around. The mural is to cover 75% of the area of the wall. So now what we need to do is figure out, well, what's 75% of 180? So you just multiply it by 0.75, and you get $1.35. So the total area of my mural now has to equal 135. But I have to figure out the dimensions. Now, if this whole chunk is 15, that means this chunk, it's 15 minus 2x because I took out x on both sides. Same thing going the other direction. It's 12 minus 2x going the other way. Those two have to be multiplied to equal 135 for the area. Now what's tricky with this problem when you set all this stuff up, you're going to get the following. You get, 180 minus 30x, minus 54x plus 4x squared is 135. I have a positive a value, which means it's going to be up like a cup. Okay. Moving some things around, I get the following in standard form. 4x squared minus 54x, and then it's plus 45 is 0. I don't want to factor that. What times what's 180 you add together to get 54. I don't want to try and complete the square with that because I can divide out. I can't divide 54 cleanly by 4. It's going to be ugly. So my two methods that I could go for quickly is I can use my quadratic formula, or I can find and calculate zeros. Now, I'll show you both methods, because we haven't done one with the quadratic yet. Quadratic formula says opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Why did I write b squared as, instead of negative 54, just plain old 54?
This is going to be a positive anyways.
And less likely to screw up. Okay? So if I multiply all that stuff onto the radical, otherwise known as the discriminant, I get the following. 54 plus or minus 46.86, then divided by 80. Which means my two possible zeros will be located at either 0.89 or 12.61. That tells me I have two possible answers for x. One of those I have to throw out. Which one do you have to throw out and why?
The point of data.
Which one do I have to throw out and why? Think about it. Yes, ma'am. Exactly. You got to throw out the 1261, guys. Here, stand up. Shh. Hold this. Watch. Here's my wall. My wall is 12 by 15. Here's my border. Can my border be bigger than my wall? No. 12.61 means your border is 12.61. The wall's width is only 12. It's too big. It doesn't work. You have to throw it out. So the answer is going to be, instead of rounding to the nearest tenth, it means your answer would be what? Nearest tenth. 0.9. So that's the reason why you get two possible answers, but only one of them is feasible. Only one of them is within the feasible realm for the problem. That's the 0.9. So you just toss out the other one. So yeah, you have to go back and think about, well, the original dimension of the wall is 12. I can't have an x value here of 12.61 and a 12.61. That means the mural is already double the size of the wall. I'm no math major, but I'm going to say that doesn't work.
Well, that's why you have a math major check your work before you start painting.
Hey, what?
That's why you just wing it and have a math major check your work before you start painting.
Or that's like, hey, what much do I tip? Shut up. The decimal and multiply by 2.
What?
That's how it works.
No, actually, seriously, that's
No,
how it
seriously.
works. Well, which way? Right or left?
10%.
What do you think?
$1,000.
So if I'm going to, and then you round,
Nice.
and then you round it, you do plus or minus the whole number then. If my bill is $26.75, I'm going to go to the right and give them $267.
Yeah.
You're generous.
I am a generous, kind-hearted person. I can't even say that
Another one?
Notice the two sections that are taken out, one of which we didn't do. The other one, you just press buttons on your calculator. What's the point? I don't need it. 5.4 basically tells me, 5.4 was the one where you would simplify your, you would rationalize denominators if you had I values in it. We now know with the fraction bar it does it in the calculator. We don't need to worry about foiling out with I values. I don't even care that you guys remember I to the negative, or I to the 5th power is going to be -1 or whatever, because, let me finish. You don't have to rationalize and do that because those values you can press in your calculator. But it still means that you have to know that if you get x minus 9 quantity squared equals -15, you still have to be able to do x equals 9 plus or minus I root 15. You have to be able to do that. But I don't care that you don't have to know what is 3 plus I over 2 plus 3I. I don't care about that problem.
We don't
Because
have
you,
to do that anymore?
no, because you use your calculator. It's a point. Okay?
More points is the
Next year, well, you guys don't understand. If the points were there for that and you get it, that means there's still the same amount of points there. It doesn't matter if it's there or not. Why waste your time? That's the way I look at it. If the points aren't there, then the points aren't there. It doesn't make a difference. It honestly doesn't. When you get into the rest of it though, remember, 5.1 is all about graphing. We had 3 forms of graphing: standard, vertex, and intersect. Each one of them had their own little idiosyncrasies about how they work. And those kind of worked also in tandem with 5.8. 5.8, we looked and worked with them by writing the equations out, given a vertex and a point, and backtracking it through. Okay.
Did we ever get that quiz back?
What quiz?
The one we did that.
I agree.
one that was terrible.
Yeah, that first one? Yes. Yeah, you guys got that back.
No, we did.
No,
The one we
the
did
other
that.
one we did, the last one we did.
I don't want it back.
did.
I don't want to look at it.
I swear.
And then he realizes.
I'm sorry.
No, I
I'm
don't
sorry.
want
I will. I'll get him. Let me finish this out. I'll get him. I'm sorry. I swear I did. I'm sorry.
10 plus 1 on Monday. I asked you one day.
I thought I did. I'm sorry. I really am.
I
Okay.
don't want
So remember, The 5/8 stuff, back and forth with the 5/1 about how you work with the equations. How do those work in tandem with one another? How do you write the equations out? Remember, when you go with standard form, we used matrices. You press some buttons. It's pretty quick. 2, 3. 2 and 3 were solve the equation, solve for x. Some were factoring, some were taking square roots, some were working through using quadratic formula. Quadratic formula, discriminant, how many zeros? If you have a discriminant that's positive, how many zeros do you have and what type? If it's 0, how many do you have?
Wait,
One.
Which one is that?
And is it real or negative or imaginary? Real, and then
Which unit
2
was that?
negatives would be imaginary. Okay.
Is that 5, 2, 5, 3?
I think that's 5, 6 to be honest with you. 5, 5, complete the square. It's everything's online. Every section is there for you. Open it up and read it. Okay? Everything is there.
Jeez.
All right? I'm not gonna, you want me to just give you the test right now so you can copy it down and then you just come back tomorrow and regurgitate it? No.
Sure.
Yes. Guys, everything is there. We've done every style problem. I'm pretty sure we've done every word problem that the book has. If I went through the new book past couple of days looking for more of them. There aren't any more of them. We've done them all. Yes, sir. What do you think my answer to that question is? I don't know. Okay. This is all old book. The new book for quadratics is pretty late. It doesn't even incorporate imaginary numbers into any of the quadratics.
Why did you buy the book? Or some other book.
Because we have this book already for the Algebra 1 class, it works rather well for them, and they have a nice online platform that works for the Algebra 1. It didn't work for us at all. That's why we haven't used it. So that's why we didn't have time to go back and try to make sure everything was fixed and working yet. We will get into the online platform for this. Probably it won't be with the conic stuff, but it will definitely be. Well, maybe I'll look at it this weekend. I think it might have some of it, but we will start to use more of the online platform as we go along. So we will start getting into it. This old book, the older book though, does have a little bit more of the level questions that I want, and that was a lot of things versus the other algebra classes. I'm backfilling with some of these older, better problems. Other than that, I mean, completing the square, there's really only one rule for completing the square, and that was basically that your A value has to be what? 1. Your A value has to be even. Your A value has to be 1. It's easier when your B value is even. If it's not, you can still do it, it's just a pain. Yes, sir? Well, never mind that, I won't talk to you. How about that? Let's see, what else was there? I don't know, what else you got a question on? I mean, that's pretty much everything's through there. The problems that I was saying that I was going to look at is if you go back and on the actual website itself, oh, this didn't open right. Let's do this, it's easier. If I go back here, and we're going to click the old Algebra 2 book, the only stuff that we have open in here is that couple of problems from chapter 3, which I'm not worried about. But here's all those sections. 1, 2, 3, 4, 5, 6, 7, 8. But I also threw in the summary, like basically your chapter review.
Oh, thank you.
You throw that in there, and it has examples
That's very nice.
of everything, okay?
That's very
I don't have the answers there. Someone else did ask about that. If you want to just take a picture of the answer book before you go ahead. Otherwise, I'll take a picture and try and post it on there, and I'll throw it up on the website later on. But I'll try to get. I think I'll be able to. I should have time to finish that out tonight without a problem. But all the answers are all right here. Or sorry, all the problems, really good problems here. Just solve doing this, solve doing that. Don't worry about the graphing part with the inequalities. We have not done that. The modeling portion, there's your 3 examples. There's a vertex and a point. x-intercepts, and a point. 3 points on a graph. Those are the 3 ways that we did it. There's extra problems here on the chapter test portion. The two word problems that are on the chapter test really don't make any sense for what we've done. If you notice, the first one talks about a waterfall, and it's asking you to come up and write your own formula. If it's anything that has an initial velocity style problem, like being shot or anything like that, I'm going to give you formulas. I'm going to give you the equation to start out. I'm not going to make you try to figure that out. The only ones that you have to come up with on your own are those cost sales ones. That's the only ones you have to make on your own. Okay? What's that? Did you forget what that was? Okay. Okay, good. Yes, you're fine. Thanks, buddy. So things like that. There's just a bunch of extra questions here. By all means, I know we have our first, actually it's October. I haven't even had a staff meeting yet. We have our first staff meeting tomorrow, which is weird. Would have actually been on Friday before we have our Institute Day, but whatever. So I probably won't be back up in the room till like 7:30, 7:35, so I might be a little bit later than I normally am here. But by all means, everything's there for you. You get the answer book out, and if you guys want to take sure of the answers with how these things work, doesn't matter to me. Yes, ma'am.
Yes.
No, I'm not. When I get to the review stuff, guys, this is big girl, big boy math and stuff. It's up to you. You'll figure it out. Yeah, no, there's certain things that you probably know how to do without a problem. There's certain things you probably don't remember and all that. Yeah, there's a couple of pages here. One question, and then it just goes to here. So I'll just leave here. Knock yourself out. Not literally. Do me a favor. Pass that around to second hour. If you know any of those bozos in there, send them that also so they can send it around. Please and thank you.
So is Brad.